move into the physical, build the database, and suddenly at the end of that find out that something the user would not have signed off on something from way back in the conceptual phase. Because then we've got to go all the way back there, fix the problem there, and then go through that whole other process again. Okay, so earlier is better. We want to get a thumbs up. We want to get a go ahead on the conceptual model. Okay. All right. So let's look through an example. Okay, and we're gonna build through a model from the staff property for rent. Okay, from some of the aspects of the dream home case study, the dream home example we've been using so far in this class. So notice that we'll have this idea. Okay, so from the description of the system, we'll say this is what an entity could be. This is a description of what that entity would be. Aliases are important, and we won't get into it today, but aliases become important for when we get into the logical phase if there is a need to merge two designs together. The reason for this is for really large systems, it's very rare for one team to design the whole thing. Usually what happens is, especially for large systems and complex systems, is multiple teams work together. And sometimes they're not even physically in the same building. There was one company I worked for where we had a team that worked in one part of the country and another team that worked in another part of the country. And we would communicate through email and through other types of messaging services. This was back before the days of WhatsApp and before the a lot of the nice fun stuff that you guys have. But we would communicate as best we could through emails and through telephone calls and stuff like that. But the point I'm getting at is what happens if a part of the system I'm working on overlaps with a part of the system that another team is working on. Okay, that means that we may have some of the same entities. So in a database example, we may have some of the same entities we're designing, where I'm designing an entity for staff, and they are designing an entity also for the same type of thing, a person employed by a company. That's what we might define the staff person as. Okay. Now, if most of my literature, most of my documentation that I have refers to staff over and over again, I may call my entity staff. And if most of the documentation that the other team has refers to employees a lot, they may call their entity employee. And then what we're going to do is when we go to make one big system out of it, what do? We have one entity called staff and one entity called employee, but really they represent the same thing. And so we've got to put those together somehow. And we'll talk about that next week, next week, when we talk about the logical design, especially the merge step of the logical design. Okay. So basically we have the entity, we're defining the entity and what its purpose is and how it occurs. Okay. And then so we may have like an initial ER diagram. Now, be prepared that your first ER diagram will not be your final ER diagram necessarily. Okay. You may end up redrawing this thing a number of times. That's one of the reasons why I highly suggest, excuse me, I highly suggest that you use a tool like what I showed you guys last time about the draw.io or diagrams.net, or if you have some other type of tool like that, is to use a tool like that, because if you draw these things out by hand and then realize that you've got to make some changes, and then you've got to erase, and it just can get really, really difficult to edit a diagram if you draw it out by hand. Okay, so we live in a time where we have access to a lot of digital tools to be able to help us do these things well. Okay, now specifically, if we look at here, okay, if we look back at this data dictionary, where staff, each member of staff works at one particular branch. Okay, so the way that would get represented here is we have staff. Where's branch? So actually, I guess they did not include branch as part of this. I think it must be later here. Maybe it's part of the bigger diagram. Okay, we'll get to it. So if we had a branch entity, which I guess maybe that's the other team. The other team is doing the branch stuff. We're just doing the property stuff. Okay, but a staff would be at a branch. Okay, but the other part of this was, each property has a single owner and is available at one specific branch where the property is managed by one member of staff. So, okay, so property is managed by one member of staff. That means it has a relationship with staff. Okay, it has a single owner, which means it has a relationship with owner. And a property can be viewed by many clients, rented by a single client at any one time. Okay, so what that means is we have this property for rent, managed by a staff, only one staff. Now the reason for this 0 over here, the reason for this 0.1 means that it doesn't have to be managed by a staff, but if it's not, then it must belong to a branch. And we talked about this with the one of the traps, the chasm trap, I think, with the property for rent staff branch situation, right? Okay. But now one of the things that you may notice here is, okay, a client views many properties. A property can be viewed by many clients. Okay, but let's look over here on this side, because that first part is it must be owned by one owner, right? That's this whole business owner, private owner thing. Has a single owner. Now, a property can be owned by a business owner. It could be a business property, like a company or something. It could be a private residence. It could be a home, right? And it could be owned by a private owner. Now, the problem is that there is a requirement hidden in here that's not visible through just the diagram. And that is that a property can only have one owner. Okay, it can only have one owner of either type, right? See, the way this is drawn out, the way this diagram is drawn, a property could have 0 owners, right? It could have no business owner. It can have no business owner. It could have no private owners, which means it is possible that a property in the database, the way this diagram is drawn, could have no owners at all. That's a problem, right? A property must have an owner in order for us to be managing it. Okay, so we would have to make a note somehow that a property must have one of these two. Okay, the 0 can only apply to the other one. So if it has a private owner, it can't have a business owner. If it has a business owner, it can't have a private owner. Right. The other problem of that is the way this diagram is drawn out, as it currently is that a property could have both one business owner and one private owner. But that's also a problem. It can't be both, right? Like a property can't be both a business and a home, at least not in our system. All right. So again, we would have to make a note that it has to be one or the other. It cannot be both, and it cannot be neither. All right, it has to be an exclusive or, basically. All right. Now, what we're going to see later on is that we can use those enhanced modeling concepts to be able to fix this problem right here. Okay, to be able to make it understandable. Okay. Same thing with this recursive relationship. We'll see how we use the enhanced modeling concepts to be able to make this a little bit better. Okay. Right, and so then now we have this is how the property for rent is related to the client for if someone rents an apartment. Okay, so property for rent, it can be associated with a lease or many leases. Can be a client can be associated with the lease, but notice that if a lease exists, it can only be with one client. It can only be with one property. A lease represents a client renting a property. Okay. A lease represents a client renting a property, which means it can only be one client and it can only be one property. They can't be, a lease cannot represent two clients renting the same property or anything like that. Okay. Notice the zeros on each side here. The way that we would interpret that, the way that we would read that is that a property doesn't ever have to be rented. It would make sense if it's a new property, or if it's a bad property, or nobody wants it, something like that, then it might never have been rented, and that's okay. We're still managing it, we're still tracking it, even if it's never been rented before. Same thing with the client. The client, it could be a new client. They've created a username, they've created a profile on our system, they have looked at some properties, but they've never actually rented one, and that's okay. And that's the way we would see this, is that a client can have many leases. It can also have no leases. Okay. One thing that I would tell you is we could have also represented this, right? Instead of this lease entity, as far as the diagram is concerned, we could have represented this as a single many-to-many relationship with the property for rent table between client and property for rent. That would be the rents relationship. We could say a client can rent many properties. Okay. All right. So here is some information, right? So a non-diagram view, a non-model view of some of this, where we would talk about some of the relationships between other entities. So a staff manages a property for rent. A staff supervises other staff. A property for rent is associated with a lease, those kinds of things. Okay, so this would be the same as this diagram over here, just in a more of a table format. Okay. Some other things that we might get from this is we would get our attributes, so a list of attributes. So we're going to say what some of the attributes are for staff, what the description is, what type of data this could be, right? What data types, 5 characters, 15 characters, 1 character, that's a date, those kinds of things, whether or not nulls are allowed. And remember, one of the things I said was we would be moving from the conceptual, from the idea of what the database is, and as we move through the different phases, conceptual, logical, physical, we're going to get closer and closer to a data definition language. What I said was SQL, but let me be more general with this and say a data definition language for how we're going to create the database. So hopefully you could look at this and already say, okay, well, I could take this right here, this staff entity, and I could write a create table statement from that. I could write a create table statement that would create the table staff, would create these attributes of these types, and let them be nulls or not. All right. Hopefully you could do that, and what we'll see is in the next phase, it'll get even closer. It'll get even closer to that SQL format. Okay. All right. So then we're going to have some other entities with its attributes and stuff like that. Okay. All right. So here sometimes, so the main reason I wanted to get into this was because this here is the diagram is a way to be able to very quickly see the entities and their relationships. If we start throwing all the attributes into this diagram, you know, each of those entities gets really large, like the block gets really large, right? So this